Welcome back, 7th grade team. Again, I'm Mrs. Allen, the math coach at Bouchal Middle School, and we are going to continue our probability journey. And as a reference, we want to keep in mind that our weekly learning target for this week and next week is to be able to determine the theoretical and experimental probabilities of an event. Please be sure that you have your supplies for today's lesson because we definitely want you to be prepared, even if it means you need to pause the video to go ahead and gather your supplies. You're going to need your notebook and your pencil, your calculator, considering the examples that we discussed, an I can attitude. And for today, we want you to have the probability accessory mat that is able to be printed off on your learning plan, including a number cube, a deck of playing cards, and one coin. And these three items actually are common items that you might have around the house, and any coin will do. You will have a total of 4 independent practices each week. And when you come the next day, you will have your independent practice answer key to compare your answers with. This is why it is important to make sure that you show your work, because if you do have an answer that is incorrect, this allows you to go back to see what the mistake is that you would have made. So our independent practice from yesterday was 4 questions specifically related to theoretical probability. Pause the video for a moment and go ahead and check your independent practice work. When you return, we can resume the video. So our daily learning objective for today is to be able to determine the theoretical probability of an event. And today we have a learning partner who is visiting with us for today's lesson. Alicia Mosby is our learning partner, and she is a rising junior in the IB program at Thomas Jefferson High School. She is going to join us to take a closer look at 3 common tools we see when we perform probability exercises: our number cube, our coin, and playing cards. Now, this is the portion of today's lesson where we will use these tools with your probability accessory mat that again is located in your learning plan.
Hey everybody, my name is Alicia Mosby. I'm a rising junior at Thomas Jefferson High School, and today I'm going to be doing a worksheet on probability for you guys. Hope this helps. Okay, first we're going to be talking about coins. As you know, a coin has a head and a tail, so that means it is total sides of 2. 1 head and 1 tail. Next, we're going to talk about number cubes. Number cubes are dice real world. They're ranging from numbers 1 to 6. So there are total sides of 6. 2, 4, and 6 being our even numbers, and 1, 3, and 5 being our odd numbers. Next, we're going to talk about a deck of cards. There are 52 cards in a full deck. There are 26 black cards and 26 red cards. There are 26 of each color in a deck. The cards, there are 4 suits, 13 clubs, 13 hearts, 13 spades, and 13 diamonds. Each group has 1 of each suit: 1 heart, 1 club, 1 diamond, and 1 spade. This helped y'all out a lot. Thanks for watching. Stay safe.
I want you to feel comfortable pausing this video if you need a few more moments to complete the probability accessory mat that Alicia was showing us. Now that we've reviewed the characteristics of a number cube, I want you to try this next problem on your own. Pause the video, apply your problem-solving strategies, and then we'll take a closer look at this problem together. So after reading this question all the way through and applying our cubes method, we underline the question, which specifically is asking us for the theoretical probability of rolling a 3, 4, or 5. Now, this is an interesting word problem because if we notice, it gives us information about an experiment that Jaden is conducting. However, then it tells us that we are just looking for the theoretical probability of landing on these three numbers on a number cube. And again, theoretical probability is when we are looking for the chance that an event can happen. It's not based on an experiment, it's that an event can happen. So we know that there's one number 3, one number 4, and one number 5. So that would be a total of 3 for our favorable outcomes out of 6 for our total possible outcomes. We want to simplify the fraction as 1/2, which is the equivalent of 50 hundredths and 50%. How did you do? So we want to spend a part of today's lesson on an extension activity where we are finding the theoretical probability of an outcome using sample spaces. It is always great to connect to the things that you previously learned to keep them fresh. Now in 5th grade, you learned how to make a tree diagram using a table, list, or chart that tells you all possible outcomes of an event. And we see some of those examples right here on our PowerPoint. Now this relates to determining probability. But rather than finding the probability of one event, such as flipping a coin, we would use this to determine the sample space of a combination of events. Let's visit with the Cyber Squad and watch them produce the combinations for a game and determine their theoretical probability of winning.
We're looking for a very special kind of game.
Hey! Watch it! I mean, watch a madman show you special game. Game is called 4 Zergens in Hat. 4 Zergens. Number 1, 2, 3, 4. See? No tricks. Pick 2 Zergens from hat at same time. Multiply the 2 numbers. If answer is even number, kiddies lose. Odd number, kiddies win. And Katrina, they dip in water.
Ew! That water's disgusting. What if we lose?
Then you take a dip in the water. You play.
Hold on a sec. What do you think, Lucky? I've never played this game before.
Well, someone has to. I'll play.
Splendid. Take seat, my charming assistant. Get odd number. This cutie hat is yours. No biggie.
No problem. Oh, no. 1 times 4 is 4, an even number.
Oh, too bad. You lose.
Maddie? Digit!
We want our friend back, now!
Ooh, Kitty's upset. Do you want to play again?
We should have given this game a fairness check before Matt played.
We'll be right back.
Madam Ann be waiting.
The only way to find out if this game is really fair is to figure out if everyone's chance of winning is the same. While you do that, I'll nose around for Matt.
We need to know how many pairs turn out odd and how many turn out even.
Let's say we pick a 1. That means the other number could be a 2, a 3, or a 4.
Cool. Now what?
Well, if we pick a 2, what other numbers go with it? A 2 and a 1, we've already got that.
So the other pairs are a 2, 3, and a 2, 4. And what if we picked a 3 first?
Then the only pair we don't have is a 3 and a 4. 1, 2, 3, 4, 5. There are only 6 different combinations.
So, like in the game, let's multiply the pairs of numbers and see how many come out odd and how many come out even.
2, 3, 4, 6, 8, 12. Look! 5 of the 6 pairs come out even.
And only 1 pair comes out odd. Since we win when the answer's odd, we only have 1 chance out of 6 of winning.
And Madame has 5 chances out of 6 of winning.
That's not only unfair, it sounds like a trick.
And that means hacker.
And Madame had the advantage in the 4 Zergens game. And the Cyber Squad was able to use math to calculate the theoretical probability of winning the game. And so they made a list and they discovered that they only had a 1 in 6 chance of winning, and that the game was not in their favor. But this is an example of how we can use math to strengthen the decisions that we make when we're using probability. Now, we can also use a table to help us determine theoretical probability with combinations. And suppose we're at King's Dominion with our friends, and you have enough money for 1 scoop of ice cream and 1 topping. And so we have a picture here that we're going to work with. If we randomly pick the ice cream flavor and topping, what is the probability that you'll end up with a scoop of strawberry ice cream with jelly beans? Strawberry ice cream with jelly beans. A scoop of strawberry ice cream with jelly beans. And so what we want to do is we want to actually find out all of the combinations that are possible here, and then we're going to be able to identify that theoretical probability. So we're going to use a table. And on our table, we're going to write our ice cream flavors. We have vanilla, strawberry, and chocolate. And you're more than welcome to write these out in your notes. Mrs. Allen is just going to go ahead and put abbreviations here. And then for our toppings, we have jelly beans. That's our first one. And we have coconut. We have chocolate-colored pretzels. I'm going to put a P for the chocolate-covered pretzels. And then we have M&Ms. So now let's go ahead and identify our combinations that we can choose from for our sample space. This is what we would call our sample space that we're getting ready to make. So we could do vanilla ice cream with jelly beans. So we put a V and a J. We could put strawberry ice cream with jelly beans, or we could put chocolate ice cream with jelly beans. We can also have a combination of vanilla ice cream with coconut, strawberry ice cream with coconut. That sounds different. Or chocolate ice cream with coconut, CC. We could have vanilla ice cream with pretzels, strawberry ice cream with pretzels, or chocolate ice cream with pretzels. Or we could have vanilla ice cream with M&Ms, strawberry ice cream with M&Ms, or chocolate ice cream with M&Ms. So these are the available combinations that we can have using these 3 flavors of ice cream and these 4 different toppings. Now our question asks us the probability of ending up with a scoop of strawberry ice cream with jelly beans. So if we look at our sample space, where do we see S for strawberry and J for jelly beans? We see one right here. This is one combination. There's actually only one combination in here that shows this. So now let's go ahead and identify our probability of selecting strawberry ice cream with jelly beans. Jelly beans. And again, we're looking for the theoretical probability here. I ran out of space. I'm going to write it down here below. So I have one possible outcome, that is strawberries with jelly beans, out of how many total possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12 total possible outcomes. So my probability of selecting strawberry ice cream with jelly beans is 1/12. So now it's your turn to try. How about a trip to Short Pump with some friends? Go ahead and pause the video while you complete this problem and then return and we'll check your answer. Well, let's see how you did. Hopefully you applied your problem-solving method and you underlined the question, which was asking you if you randomly pick the toppings and crust, what is the probability that you'll end up with a thin crust with pepperoni topping? You might have used a table, you might have used the fundamental counting principle. In this case, we have a table. How many total possible outcomes? 12. And that goes in your denominator. And then you have one outcome that's your pepperoni on thin crust. So the probability is 1/12, which is approximately 0.08%. So as we prepare to conclude this lesson, Let's go ahead and revisit our learning objective and our key concept. Our learning objective was to determine the theoretical probability of an event, and we continued our practice finding the theoretical probability of one event and the theoretical probability when we had combinations. Now it is time for you to complete your independent work to strengthen your ability to apply your understanding of theoretical probability. Complete the practice problems located in your Week 7 Day 2 learning plan, and be sure to justify your answers with work. Following the independent practice, log on to Dreambox and complete 2 lessons to strengthen your math skills. So let's take a look at our future considerations. So today's learning objective was to determine the theoretical probability of an event. When we return tomorrow, we actually are going to learn how to determine the experimental probability of an event. And this is a reminder, we want to know who's been learning with us. So share your avatar at Padlet. The link is available here, or you can find it in your learning plan as well. I am hoping that yesterday you had the opportunity to view the additional information and learn a little more about Clean Air Month. Now today's resource is going to continue in looking at Clean Air Month by helping you learn about wildfires and smoke, what is being done about it, and what you can do about it. So be sure to visit the resources on your learning plan as we learn about keeping our air clean for ourselves, the ones we love, and our world. And again, I thank you for coming to partner with me today. I want you to be safe. I look forward to seeing you tomorrow. And remember, make today so wonderful that yesterday gets jealous. Have a great day.